You remember the topology that I had in the class, in the previous class. I'm going to build similar topology like one customer edge, two customer edge routers on different location, and then maybe 5 provider router like this, 5 provider router with 2 provider edge routers. So this one and the first one and the last one and the red is provider edge PE1, PE2, customer edge 1, customer edge 2, and we are going to put this in OSPF. So this forms an autonomous system. And then we will run OSPF. Initially we will run from here to here. Initially we are running OSPF from here to here, or we can do one thing. We'll run OSPF here to here like a real world scenario. We'll have Mpls, and because we have already learned BGP, we will have BGP between this and between this eBGP. Let's say autonomous system 10 and autonomous system. Usually if it is same company, autonomous systems 10 will be on both sides, and you need to say allow AS, local AS. That you can do, so that the site 2 routes will be learned in site 1. Or you can have different autonomous system here. It is your wish. What I'm going to do is I'm going to have same autonomous system. But when you do, you can to reduce the complexity, you can choose different autonomous system for different sites. But in the real world, people don't spend much money in buying autonomous system for every branch office. They will try to have one autonomous system for their company, and they will use the command allow local AS so that routes can be learned. The routes, even though it is originating from same AS 1.1.1.1, can be learned here on customer edge. So this is what first we are going to do, and then we'll do some verification. The commands that I taught you in the previous class, we'll put them on all this router and verify those things. Right? This is the plan. Totally, we need 6 routers, no, 7 routers. Do you have any question? There's going to be AS10. This router is going to be AS20. This is also going to be AS20. And I'm not going to run BGP inside, no IBGP. So what I'm going to do is I'm going to redistribute this BGP routes into OSPF. BGP routes into OSPF and OSPF routes into BGP, vice versa. Later we will do layer 3 VPN. That time I'll remove these things. I'll remove redistribution. Now I'm just going to demonstrate MPLS. So the maximum reality, the maximum that I can match with the real world is I can have same autonomous system number on the customer side. But in the real world, we will not be redistributing from BGP to OSPF and OSPF to BGP, and we have MPLS layer 3 VPN. Because we don't have MPLS layer 3 VPN, because we have not gone to that level, to have route between 1.1.1.1 and 2.2.2.2 to have the reachability, I have to redistribute. That's what I'm going to do. So, anyone has got any question before I move? So this is the topology, and the devices are booting up. Meanwhile, I will go to the notepad and configure R1. Neighbor 10, 13, 02, sorry 03. Remote is will be 20. This is the autonomous system number of router 3 and 7, and this is the IP address on G00 of router 3, 10, 13, 03. I think this is not GNS3, so I have to give host name. I'll say customer edge VIOS1. Router 1 is almost ready. I'll also, meanwhile, as it is getting ready, I'll also go to router 2. Not ready. Okay, I think I have to paste in router 1 now. It is done. Router 1 is over. Similar configuration need to be done on router 2. So let's do the alteration that we need. Between router 7 and 2, the network is going to be 10.27. Later, when we do VPN, I'll change it into public to make it more realistic. But now I'm just keeping 10 network even between Ebgp. This is just, we need a network, that's all. That's not going to harm any of our learning. So router 2's neighbor will be 10.27, 0.7, and then the network that we want to advertise is 2.2.2.2, and the network that we advertise the physical interface is 27, same BGP 10, and G00 is 10.27.2, loopback is 2.2.2, customer edge VIOS2. This goes on router 2. Router 2 is also ready. Now let us finish configuring router 3. Router 3 is a provider edge. Let me finish router 7. The reason why I finished router 7 is some of it is already there. Right. So router 7's loopback is 7.7.7.7 and I'm going to run OSPF within the service provider. As I said, Mpls is only for service provider. IP OSPF 1 area 0 and G00 will be 10.27.0.0.7 and IP OSPF 1 area 0. And then we got another physical interface to configure, which is G01 10.67.7. Oh no, this one should not run OSPF. So I remove. This is WAN facing interface. OSPF runs on only the loopback and the provider facing physical interface. Okay, so now we also have a Ebgp. I'm not ready to advertise any network from the provider will not advertise any network. So we are not advertising anything from a local provider will not have any local network to advertise. They advertise only those routes coming from customers to provide reachability. Providers don't advertise their own local network to any customer, right? So I'm not advertising anything on the BGP here. BGP here is 20, and neighbor is 27002, remote AS is 10. So this is enough. I paste this on router 7. One of you have not muted your mic, but if you have question you may ask. Otherwise kindly mute. Thank you. We'll do one thing. Meanwhile, we'll go and verify R1 show IP interface brief. See, we got this interface with IP address. As per the plan, it is configured. The interfaces are up. Show IP, BGP, and we are advertising these two networks from local. And the show IP BGP summary. We have configured neighbor, but neighbor is not established. It is in active state because we have not finished configuring R3. Now I'm pasting that. Oh no, this is memory issue. Is it? Unfortunately, there's a CPU issue. Oh, good, just come. All right, boom. Okay, the provider at 7 is also ready. What we are expecting is an EBGP neighbor between 7 and 2. Let us wait for EBGP. As we are waiting, we will verify whether OSPF is properly configured, IP addresses are properly configured, and the interface status is up. Okay, the EBGP has already come. MCP has already come, so nothing to check with the right hand side. Let's check only with the left hand side. I want to check whether OSPF is running in between 6 and 7. So I'll type show IP OSPF interface brief. I already typed and hit enter. I'm waiting for the output. Due to CPU, it's not showing. It will come. Router 7. Show IP OSPF interface brief. We do see OSPF running on key 01 and loopback. 00 should not run. Show IP BGP. I want to see whether I'm learning routes from customer. Yes, we do learn routes from customer, the 2.2.2.2. 10.27 is shown as a rib failure. It is because network 10.27 is also directly connected to this router. Next. Let us finish router 3. G00, we don't run OSPF, it is 10.13.0.3. G01 is 10.34. Advanced OSPF. BGP 20 is correct, and this is going to be 10.13. We'll copy all of this and put it in router 3. We're expecting BGP neighborship and routes from eBGP neighbor. Okay, eBGP neighbor has come. Show IP OSPF interface brief. Takes time. We'll go back to notepad. This is provider only router. And the name is for G00 of this router is going to be having this IP address, and G01 of the same will have 45.4. And then there is no need for BGP. We need to run OSPF on all the interfaces. This will go on router 4. Router 4. Let us configure router 5. G01 is 56.5. G00 is 45.5. That's it. Router 5 is also ready. Next is the last router, 6. What I'm expecting is reachability between router 7's loopback to router 3's loopback. Show IP route 3.3.3.3. Still the routes are not learned. I'm waiting. We need to wait. Router 6 need to form neighbor with 5. Let's go and verify router 6. Show IP OSPF neighbor. Oh, it's still in two-way state. We need to wait. Okay, now it has come. Now let us go back to router 7 and verify. The routing table still didn't get root. We need to wait for the convergence to happen.
Sir, can we check the neighborship here?
It is neighbor. I know. Show IP OSPF neighbor. It is neighbor. So there may be a problem between. There is no problem. Convergence is the problem. Due to my CPU, the time taken is more. Show IP route 7.7. Okay, the route has come here. So I'm expecting the routes to be, yeah, it took some time. So now tracing the route to 33333, kindly focus now. The source of loopback 0. It should go to router 6, 5, 4, and 3. Tracing is also going to use ICMP. You can ping and test, you can trace and test. But ICMP type is different, but it is ICMP protocol. I've gone to router 6. And notice, you don't see any label in this trace output. You see only the time taken, millisecond. You don't see any label. Soon we will be seeing some label after we enable Mpls. That's why I'm tracing. In trace, you can see the labels that are used by Mpls. Okay, so we got the reachability. I will also show you by pinging. Okay, what is next? We would like to ping from customer 1 to customer 2's loopback 1112222, for which I need to redistribute the routes. So let me do 1R3. I'll go and say router BGP 20, redistribute OSPF 1. And likewise, I'll say router OSPF 1, redistribute BGP 20 subnets. Okay. As a result, what happens? R7 will have now the route to reach 1.1.1.1. You see, R7 has learned route. And this route is type 2, E2, LSA type 5. External means type 5. You can also see that here, show IP OSPF database. You can see it here, 1111 is type 5 because it is coming from BGP. Anyway, that's not the story here. Let us now do the redistribution on 7. Router BGP 20, redistribute OSPF 1, router OSPF 1, redistribute BGP 20 subnets. Now what I'm expecting is R3 to know about 2.2.2.2. Show IP route 2.2.2.2. You have a route. This is also external type 2. But when you go to router 1 and type show IP BGP, you don't see 2.2.2.2. You don't see all, you see all other OSPF routes, OSPF networks, but we don't see BGP 10 remote site network. The reason is the same AS. Router 2 and router 1 are in same AS, so the routes will not be accepted inside. So what we do, router BGP 10, allow locally neighbor 10.13.0.233, allow AS in 10. I need to put the same command on router 2. Neighbor 10.27.0.7, allow AS in or in 10. Allow AS in is also okay. Now I'll check. We'll check on R1. Show IP BGP. No, I'm not seeing 2.2.2.2. We'll go to router 2 and see whether I'm seeing here show IP BGP. I'm not seeing 1111. So, so the command is different. Or
So can we clear IP BGP soft?
No, wait. Yeah, that's a good idea that we can do. 1 minute. First of all, I want to check whether I did the command and okay, correct. Clear IPBGP star soft. Clear IPBGP star soft. Show IPBGP. Clear IPBGP. I'm doing the hard reset. I know the command is not that clear. I have not put that command. Okay, I know where the problem is.
That's something's a local AS, right?
Correct. That is what I have made some mistake in syntax, so I'm not getting the command. I'll find it out now. Router BGP 10. I would like to remove this. BGP. Kindly mute, kindly mute, kindly mute.
Sorry.
Neighbor 10.27.0.7. AS override is AS override. I can use on router 7. That is also a good idea. I can do AS override so that router 1 will advertise as if it is advertising. So that is one option. Ah, local AS. No, not local AS. Local AS is to change the AS number. So I'll do one thing. I'll go with that one. AS prepend command. I'll go to router 7 and say router BGP 20 neighbor. Whenever you speak to this neighbor 27.0.2 AS override. AS override. Yeah. So next is on router 3 also I'm going to do, but before that I'm going to delete from router 1 what I configured earlier. Router BGP 10. So now on R3, router BGP 20 neighbor 10.13.0.1 AS override. Okay, I should see now the roots of the remote site. Show IP BGP. No. Clear IP BGP star soft. What has happened? Router 7. Show IP BGP. This itself is not learning 1111. Okay.
Sir, one question, sir. The C1 and 2, are they IBGP neighbor?
No, I don't want it to be IBGP. I don't want them to be IBGP neighbor. So that AS override is also really not necessary. We have redistributed, no? You remember I have redistributed, correct?
Yeah, yeah.
Kindly mute. Because I have redistributed, I'm expecting the redistributed routes to come to R7. R7 is learning 1.1.1.1. Show IP route. It is learning 1.1.1.1 because I redistributed. But when I try to redistribute it to router 2, show run section router BGP. I have redistributed the OSPF one, but still I'm not seeing redistribute OSPF. Okay, I'm using match external keyword. Match external as well as internal. That's it. Likewise, I will say to the other side. Type 5 we are redistributing into type 5 as well as internal. All I'm mentioning all. So that's the syntax. R3, where are you? Router OSPF 20. Earlier I said simply redistribute sorry, not OSPF 20, BGP 20. Router BGP 20. All right. So now now the route should come. It has come. So that prepend AS is not needed because we really don't have any IBGP between 3 and 7 that you can remove. Now we got reachability. Now if I trace route to 2.2.2.2, I should be seeing the routes but no labels. There won't be any label. After I enable Mpls, you will start seeing label when router 3 forwards to router 4 and 4 to 5 and 5 to 6. But when 6 forwards it to 7, you will not see labels because of the PHP. I don't know, something is wrong with router 4. Router 4, what happened to you? Show IP route 2.2.2.2. You have root. I don't know why it has got root, but it's not going to router 4. Alright. I'll go to router 2 and trace ping first, ping 1.1.1.1 with the source of 2.2.2.2. The ping happens. So the trace also should happen now. I'm sourcing from Lubeck. The reason why I'm keen in tracing is we can see the labels used when we enable MPLS. Now if I see there won't be any labels, see router 7 has received the packet, and now router 6 is going to receive the packet. Yep. And you can see it is in autonomous system 20 BGP, and router 5 is going to receive the packet, and 4 and 3 and 1. Meanwhile, I'll go and remove that AS, not here, router 7. Yeah, in here also. What happened to router 3? Router 7, where are you? I would like to remove this old configuration. AS override, this is not needed. Without this itself, it will work because we have redistributed. Clear IP, sorry. Write to memory. No, clear IP BGP only I want to give. Let it come out first. Okay. Clear IP BGP star soft. Oh. Likewise, I would like to remove the command from here. Go to BGP, remove that AS override. Okay, next is we're going to verify. Before that, I'll go to router 1 and oh, this is still stuck somewhere. Clear IP BGP star soft. Okay, now let us go and trace route again on router 2. Next is I'm going to enable MPLS in the provider network. Okay, this is stopped coming. Let us now ping and see 2.2.2.2 with a source of 1.1.1. Okay, it's pinging. Okay, when I say a source with loopback, it is going good. It is because of the RIP failure which we saw earlier. We were not able to ping from the physical interface. Now, enabling MPLS is going to be a disruptive one. Listen again. See the trace route, it will get disturbed if I enable MPLS. Now, router 7, I'm going to enable MPLS. MPLS IP interface G01 MPLS IP. You cannot enable MPLS on loopback interface because it is logical. You cannot distribute any LDP. So now if I trace route, there will be a problem because you have not enabled MPLS on router 6.5. It will be a problem. Let me enable MPLS on 6 also, so that you will see when it goes to 5 it will get struck.
Sir,
MPLS
the label, sir, label automatic generate or we will assign the label, sir?
I said automatic yesterday. Right now we have MPLS enabled on 6 and 7. And another thing what I'm going to do is on router 5 I'm going to disable Ceph. You know, Ceph is very important for MPLS. No IP Ceph. So this all will be a disruptive one. Where is the trace route that I initiated? Or two? Yeah. Now we are expecting. Okay, 4 has replied. Okay. Let me try pinging from router 1. Okay, the ping is happening, but you know you should have Ceph. I disabled Ceph intentionally to show you that even if you enable MPLS, it is of no use. You see, we got MPLS neighbor also, but when I now ping, oh, the ping is happening. Without Ceph, there won't be label. Okay, so Ceph is disabled on R5. On other router, I'm enabling MPLS. In R5 also MPLS is enabled, but no Ceph. I'm just trying to prove you that Ceph is very important. Without that, things won't be normal. So enabling MPLS is simple. One command MPLS IP. Now, okay, you know when the problem will come. The problem will come only in the middle when you disable Ceph. So I'm going to put Ceph back, and then I'll disable after some time. IPSF, that's all, one simple command. The reason why I put now is I want router 5 to first advertise label to router 4. Go to router 4 and check this command. Show MPLS forwarding table for 2.2.2.2 network. You see, you got an outgoing label. You know whose label is this? This is the label given by R5. Let me do one thing. To get another label, I'm going to refresh here. No MPLS IP. Again, I'm going to put MPLS IP so that it will give a new label. Now you will see the same show command. It shows different label this time. So this proves that it is coming from router 5. I can also prove in one more place. Go to router 5 and type here same command, or you can also type show MPLS binding, LDP binding for the network 2.2.2.2 /32. Okay, slash is not working. Simply put 32. Okay, you see the local label on this router is 25. So router 5's local becomes the outgoing label for router 4. Now what will happen? One more thing I want to show you in router 5 and then I'll cancel Ceph. On router 5, show IP Ceph for 2.2.2.2. You can see the label. And you can also see the label on R4. Show IP Ceph for 2.2. It will show you 25. You see, it shows you 25. This is the label given by router 5. Now I'm going to disable Ceph on R5. So now if I type show IP Ceph this, I don't have Ceph running. So outgoing label is not possible. Show Mpls forwarding table. You can see for 2.2.2.2, there is only local label, but there is no outgoing label. But definitely R6 would have given already a label because there is no Ceph. There is a problem. Now ping here, the ping will not happen. You see, I just explained you the importance of Ceph. When you had Ceph on R5, R5 has advertised label, R6 has advertised label, R5 has learned label from R6, R4 has learned label from R5. Now, when you disable Ceph, the label given by R6 is forgotten by R5. Now, when R4 sends a label, R5 tries to swap with the label given by R6, but because I disabled Ceph, I don't know what label to swap. It got struck. So when you put the Ceph back on R5, and then type the same show command, show Mpls forwarding, you will see labels coming up, boom, 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 boom. And now you ping, the ping will happen. I know you might have not comprehended what I have said, only to an extent you might have understood. Take your time. The video will be available in some time. Think what we have done today.